All right, so before we get into everything, I just want to let you all know we are going to be proving all of these rules. And there will be a question of the week next week that I will be asking you to rewrite these derivations. And the reason why is because it's important that we know where they come from, and so that we actually have the time to sit down and actually understand them and really get used to them, right? So having said that, let's look at these proofs, or these derivations rather. So to start off with, the derivative of a constant. So let's say we've got a function, it's equal to a constant. Well, it doesn't matter where we're at along x, our function will always be that same value, right? So f of x and f of x plus delta x, they're always going to be c. So just from that alone, we're going to get c minus c, or 0, over delta x. Well, this is really like multiplying 1 over delta x by 0, right? Agreed? Everybody agree with that? So before we even apply the limit, we're going to get that what we're applying the limit to is just 0. Well, the limit of a constant is that constant. So the derivative of a constant must be 0. Make sense? Yeah. Thus, our first rule, the constant rule. Given any function that's just a constant, its derivative will come out to be 0. As a couple examples, derivative of 7 is 0. The derivative of 0 is 0. You get the idea. Now, the next rule we're going to look at is going to be called the power rule. But before we talk about the power rule, we need to look at what's called a binomial expansion. We're going to use this in a minute to solve our problem. But before we get there, let's go ahead and just save this on the board somewhere. X plus delta x raised to the nth power is equal to xn plus n x n minus 1 delta x plus n times n minus 1 x to the n minus 2 over 2 delta x squared plus delta x n. All right. So all this is saying is that if you take x plus delta x to the nth power, it expands out like this. Now check out what's happening. Delta x is increasing by a power up to n. X to the n is decreasing by a power. And we're adding in all of these extra terms, n times n minus 1 times n minus 2, so forth and so on, right? So over here, in between, right, like this next term to the left, this would be n times n minus 1 times n minus 2, dot, dot, dot. X, delta x, n minus 1, all to the n minus 1, is that correct? Yeah. Make sense what I mean? Is everybody cool with this? Like that's what's going to be this immediate left turn, and then for every time we're going to drop moving in the opposite direction. Is everybody cool with what I mean? Alright, I'll make it more clear in just a second. It'll be more clear no matter what. What I'm trying to say, what I'm trying to point out, is that no matter how we go about this, we're going to have all these extra terms, but they're just going to have these delta xn's in them. So looking at this, let's say that we have a function equal to x to the n. Then x plus delta x to the n, that's going to expand out with what we just looked at, right? And we're going to subtract x to the n, divide by delta x, apply the limit. So we move through all of this and we say, hey, all of these delta xn's are going to be in each of these terms, right? That's what I was trying to say a second ago. So when we go ahead and pull out, doesn't work when I have my shadow in the way, does it? But when we pull out these to the side and remove their delta xn's, cancel out with this. What we're going to be left with is xn minus xn. Those are going to cancel. We're going to cancel that delta xn and find that this is what we're left with down here. Makes sense what I mean? Is everybody cool with that? Kind of sorted? Alright. Let's look at it bit by bit by bit. So we have the limit delta x going to 0 of x plus delta x raised to the nth power minus x to the n over delta x using binomial expansion. This is going to come out to be x to the n plus, like it said, n x to the n minus 1 delta x plus n minus 1 x to the n minus 2 delta x squared over 2 plus delta x to the n minus x to the n, all of this over delta x. Now what I was saying was, notice right away drop that parenthesis, right? When we do, these are going to cancel. Is everybody cool with that? So next thing to notice, all of these are going to have a delta x. So we can factor out a delta x. When we do, we're going to get the limit as delta x goes to 0 of delta x times n to the x n minus 1 plus n times n minus 1 x to the n minus 2 delta x plus delta x n minus 1. I forgot the over 2 here. All over delta x. Is everybody cool with this so far? So this delta x and this delta x are going to cancel. We're going to be left with the limit as delta x goes to 0 of n times x n minus 1 plus n times n minus 1 times x to the n minus 2 times delta x over 2 plus dot 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 delta x to the n minus 1. Well, check it out. All of these terms have a delta x over here, right? So this thing goes to 0, and this thing goes to 0, and all the things in between. Make sense? Because each of them have a delta x. So
why does that one go to 0?
What is this one?
Yeah. Oh, okay.
Because of this delta x here. So you've got delta x. The next term immediately after this would be delta x squared. And the term immediately after that would have a delta x cubed, delta x to the fourth, up until we got to delta x to the n minus 1. Is everybody cool with this? So because of that, all those delta x's are going to 0, anything times 0, 0, and all that's left is just this. Does this make sense to everybody? Yep. Cool. So, again, this is called the power rule. And what we've just found is that the derivative of x to the n is going to be equal to n times x n to the n times x to the n minus 1 is what I'm trying to say. Voila, the power rule. This was the rule that I used the other day to know what the answer to that problem was. So as a couple examples, one in particular that I'll look at two. Let's look at A and B. In the case of A, it's pretty straightforward, right? X to the n, well, n here is 3. So the derivative is going to be 3 times x to the n minus 1, or 2, right? Everybody cool with that? Now, it's worth noting before we go any further that anytime you see something like this, right? Where whenever m is greater than 0, that this thing is going to be equal to x to the negative nth power. And using that, we can solve any of these problems with fractions like this, right? Makes sense what I mean? Having said that, what's going to be the slopes of this graph at different points? -2, -1, 0, 1, 2. What do y'all think? Well, by power rule, we're given that f of x is equal to x squared. By power rule, we know that the derivative is going to be equal to 2x. And we know the derivative gives us the slope of our graph at different points, right? Yeah? So since in a second we're going to see that all of these are already calculated for us, I say instead of doing that, let's try to find the equation to one of the tangent lines. In particular, let's find the tangent line at x equal to 2. So to start off with, we're going to want to find what that slope is. That's going to be the derivative when x is equal to 2. It's going to give us 4. Agreed? Well, let's mark this as m for right now. Let's also note that our function at 2 is also equal to 4. Coincident. This is blah blah. Words are not working for me this morning. I did not sleep well. Anyhow, all right. So this is going to give us our x naught, y naught is equal to 2 and 4. And we know from point slope formula that the equation for the tangent line can be found from the following equation. Right? So now plugging everything together. So far? So all of this tells us that the line, or the equation I should say, of our tangent line to our function x squared at x equal to 2 is going to be well, 4 times -2, it's going to give us 8, plus 4, it's going to give us 4. Everybody cool with that?
It'll be a -4.
Everybody makes typos, don't hate yourself if you do. gonna give us the equation, or this is the equation, of the line tangent to our function when x is equal to 2. To give you an idea of what that looks like, what we just found was the equation for this line right here. My bad, with the tangent line up here. Right? Make sense what I mean? Having said that, we could run through and find all the different slopes at these different x values. So, just something to remind y'all of. The limit of c times a function is going to be equal to c times the limit of that function, right? Just go ahead and store this in the back of your mind because, like it says, we're going to need this in just a second. You're going to need it right now. Okay, so to find the derivative of c times a function, we're going to have c times the function evaluated at x plus delta x minus c times f of x divided by delta x. Then we're going to say, hey, we can factor out this c. Because we can factor it out, we're going to get the limit of c times this thing. But using that rule we just solved, we can pull out that c and just evaluate the limit of this, right? Well, this thing is going to be the limit, it's going to be the derivative of our function. So this is just c times the derivative of our function. In other words, anytime we have the case where we want to find c times the derivative of c times our function, that's going to be equal to c times the derivative of our function. Okay, so why don't we all try A really quick? See what you come up with that.
Does that say 1/2 or does it say 3/2?
It's 1/2.
Okay, thank you.
Yes, sir, not a problem. So who thinks they figured out what A is? Alright, well let's check it out. In the case of A, when we apply the power rule, we're going to subtract 1 from 1/2, right? Well, that's going to give us negative 1/2. And we're going to multiply by 1/2, right? Because we just pulled down the power. And then replace it with the power minus 1. Agreed? So what we're going to get, in this case, is going to be 1 over the square root of x. Or x to the negative 1/2 power. Is everybody cool with this? Cool. So, just as a couple more examples, 3 different functions. Each can be thought of as a function times a constant. So their derivatives are going to come out accordingly. Okay. So let's check out B here. Say what? B. So what we've got for B is y is equal to 5 divided by 2x, that quantity raised to the 3rd power. Step number 1, let's simplify this as much as we can. Agreed? When we do, this thing is going to come out to be 5 divided by 8 times x to the 3rd. This thing can be rewritten now as 5 over 8 times x to the negative 3rd power. Agreed? Yeah? Okay. So applying power rule then, we're going to get 5 over 8 times negative 3x to the negative 4th. Right? We brought down the power, and then we replaced it with 1 less. Yeah? So altogether, this is going to come out to be negative 15 over 8 x to the negative 4th power. So, looking at it over here, notice all they've done is they went ahead and said, let's pull this underneath, right? Either case is correct. actually personally prefer this, but I would accept either answer. Is everybody cool with this? Yeah? Cool. Alright, so let's look at B again. In the case of B here, we've got 2 times the cubed root of x squared. Well, the cubed root, that's going to be like 1 over 3, right, as a power? Agreed? Anytime we have this is equal to x to the 1 over n, right? So what we're going to get then is that this thing is equal to 1 over 2 times x squared to the 1/3 power. But hey, we have another rule that tells us x to the m, that quantity taken to the nth power, is equal to x to the m times n. Right? So what we're going to get then is that this all comes out to be 2 times x to the 2/3 power. But hey, this thing can be rewritten as 1/2 x to the negative 2/3. And now we can apply the derivative to it. We could have applied the derivative to it before, but it's easier to see in this form. Because what we're going to get now is that y primed is equal to 1/2 times, we're going to pull down that negative 2/3, right? And then subtract 1 from our power. Is everybody cool with this? So, simplifying this power first. It's going to come out to be negative 5/3, right? Because 1 can be rewritten as 3 over 3. Negative 2 minus negative 5. Minus negative 3 is going to give us negative 5. And now we're just going to multiply that 1/2 all the way through. Distribute it, right? When we do that, we're going to get negative 1/3 x to the negative 5 over 3. So let's check it out. half times negative 2/3 times x to the negative 5/3. Exactly what we've got for you. So as a rule of thumb, it's gonna help if you try to rewrite all of your radicals as powers. It's gonna make things a hell of a lot easier. Generally, mathematicians don't even use radicals just because how easy is it to misread this as 2 to the 3rd power, right? Or to not even pay attention to the 3 entirely. So generally, like I said, mathematicians don't even like radicals. We just use powers instead. Having said that, let's keep moving on. The sum and difference rule. This looks like a beast, it's really not. The sum and difference rule just said, hey, let's say we have this function h of x. And it's gonna be equal to 2 other functions added together or subtracted from each other. Then the derivative of our function h of x is gonna be our traditional derivative, right? When we pass x plus delta x through h, we're gonna get f of x plus delta x, right? Plus g of x plus delta x. That's where this comes from. H of x, we're just gonna distribute this negative through. We're gonna get minus f of x minus g of x. Well, hey, notice I can rearrange these now. You get it looking like this, right? And this fraction we can break up into 2 other fractions. And then we can apply the limit uniquely to both sets of fractions. But this is a derivative of f of x. This is a derivative of g of x. So we get that the derivative of the sum of functions is equal to the sum of the derivative of the functions. Similarly, we're going to get the same thing for the difference of functions. Sum and difference rule. Alright, so we've got this polynomial now, right? X cubed minus 4x plus 2. We can think of each term of the polynomial as a function. So x to the 3rd is a function. 4x is a function. And 2 is a function. When we do, we're going to get that the derivative of this thing is 3 times x to the 2nd power minus 4, right? Like that's all it's going to be. So let's look at it really quick. Let's throw it all through and do it on the board. doing here is we're saying the derivative of this function is equal to the derivative of each of its terms added back together, right? And if we wanted to find what it is at a particular point, like 1, -1, we would just throw the 1 back through, right? Is everybody cool with this?
And so then you would just throw 1 in there and then
That's all we would do. We get that the derivative is 3x squared minus 4. We want to know what it is at the point 1, -1. So we throw 1 back in. Having said that, why don't you all find the equation for that tangent line? I'll give you all about a minute to do that. So, to find the tangent line, we need to know two different things, right? What the derivative at a point is, and what the xy value is associated with our point, right? Like, we need to know what the point is according to our function. So, plugging in 1 to our original function, we get out -1. So we know our point is 1, -1. Then we find the derivative at that point, which happened in this case, it came out to be -1. It's a fluke that it's equal to our y value. And then from there, we just apply point slopes formula. And that's it. And when we do, in this case, we find that our tangent line is equal to y equal -x, which, looking at this, it's about right? It goes through our origin, it looks like it's about y equal to -x. Having said that, what time is it? Awesome, time for class to be over. All right. I will let y'all go. If y'all have any questions, by all means, feel free to ask. When it comes to doing your homework this week for part 1, I do want you all to actually do all these by hand, all these limits. As a way of encouraging all to do that, I am offering extra credit if you'll show your work. So do your work on a piece of paper and submit it to me by email, and I will apply extra credit to your grade.
Take several papers from the homework, so I just send them all to you? Or are you
Yeah,
talking about the
just
new
like
homework?
the new homework.
Oh.
Yes.
Yeah. Just week 4, part 1 homework. Like
Got
just
you.
your work for that.
I'll keep that, I'll take that.
Yeah.
Okay, cool.